The water wheel has changed little in the past 2,000 years. Powered by a single draft animal, it is, like the plow, a simple but effective piece of technology. But is there a need today for newer tools? And what effect does imported technology have on production and the small farmer? Can such technology perhaps be scaled down and manufactured locally? What is the best way to produce more food? Can developing countries ever hope to be self-sufficient in food? There are other demands on the land. For instance, how much should be used for pasture? And what about cash crops like sugarcane and the industry that goes with them? Then there's natural resources. How fast should a country exploit them? And are there really practical alternatives to fossil fuels? Windmills, for instance. Or maybe solar panels. Hydropower may be better in some places. But what effect does such large-scale development have on local people? How can clean drinking water be provided in rural areas? And what technology is needed to treat wastewater to keep it from polluting the environment? The cities of the Third World are growing at a staggering rate. People need places to live. Are partly built homes on serviced sites a workable, low-cost solution? People also need jobs. What kind of industry should planners encourage? And what of women? How do their changing roles affect their societies? For them, as for all Third World people, the development of new ways to improve their food and water, their health, shelter, and employment involves many difficult choices. The people of the developing countries must find their own answers. They must strengthen their capacity to carry out scientific research in their own countries if they are to make the right choices. In Malaysia, Ong Ai Wa is studying the effects of the rapid introduction of industrial development on rural households.
Semalam ada bayaan show TV ke apa-apa. Ada naik bus, bapak mak.
In this village, an electronics components factory has been built. Many of the young village women work there to earn extra income for their families. They work and live in two different worlds. Researchers study how they cope with this changing situation. How does the change affect traditional lifestyles, marriage patterns, birth rates, family structure? Such studies can help countries choose development policies that will help ease the transition from the old world to the new. The farmer, too, must learn to adapt to change, but he is cautious. He is reluctant to risk his livelihood on new crops or technology. The scientist must first learn from him, and then offer him an alternative that will work. This Sri Lankan rice crop is bound to fail because there is not enough water left in the irrigation tank to sustain it until harvest. But in the nearby village of Walagambahua, the harvest is already in. Now they are preparing the fields for a second crop. Farmers here took the advice of government researchers and planted a new, fast-growing rice. They used the monsoon rains to irrigate their fields. Their tank, part of a centuries-old irrigation system, is still full. They may even be able to grow a third crop with this water. And in the uplands above the tank, the land is being cleared for planting other crops. New varieties of cassava, for instance, and grain legumes such as cowpeas. Here, improved varieties of traditional dryland crops such as sorghum also work well. The researchers have developed cropping patterns suited to particular areas. By following their advice, the average farmer's income in this village has increased by 125% in just 1 year. And the greater variety of foods available means that the diet of the people has improved as well. Around the world, scientists are working on improvements to traditional crops, such as quinoa in the Andes and sorghum in East Africa. But much of the increased production may be lost unless it is accompanied by improved handling, storage, and processing techniques. In Botswana, dehulling sorghum, the traditional way, is a slow and difficult process, a bottleneck in the food supply line. And as more and more women work away from home, and most children now attend school, there is simply no one available to pound the grain. Increasingly, families buy prepared cornmeal at the store. Much of it is imported. As a result, local sorghum production suffers. Scientists at Canada's National Research Council in the prairie city of Saskatoon were asked if they could find an answer. They designed a simple, small-scale dehuller that could be used to process large or small quantities of grain. The machine removes the hulls by rubbing them off with ordinary grinding stones. The Rural Industries Innovation Center in Botswana has adapted the design to suit local conditions. The machine is now being manufactured in that country and is being adapted for use by several other nations. It is versatile enough to dehull not only sorghum, but a variety of grains, such as cowpeas, millet, and maize, leaving them ready for milling. Getting such research results to scientists around the world is a major development problem that is slowly being solved. The Sorghum and Millets Information Center in Hyderabad, India, is one of 5 specialized agricultural information centers, each dealing with different crops. These centers keep scientists informed of the latest developments in their fields by publishing regular bulletins and responding directly to requests for the latest scientific literature. In the Philippines, the Agricultural Information Bank for Asia is a modern computerized information clearinghouse serving the entire region. Every year, this center, and similar centers serving other regions, receives and distributes thousands of scientific reports dealing with every aspect of agricultural research. The regional centers provide a vital link between national centers, such as the Agricultural University of Malaysia, and IDRC, the global system operated by the United Nations Food and Agricultural Organization. At the National Center for Agricultural Documentation in Tunisia, much research data is stored on microfiche, which makes it possible to keep an entire library in a single cabinet.
Non, c'est-à-dire, ça c'est le numéro ISN, numéro d'ordre du fichier.
The mini-computer, too, is compact, relatively inexpensive, and easy to operate.
Vous avez vu, c'est classé par ordre d'affectation.
Using a specially designed software package known as Menisys, it enables the center to participate more fully in the regional and global networks. The computer has become a modern new tool in developing countries' efforts to increase agricultural production. Up-to-date information is also needed for research on shelter belts and windbreaks. Young scientists from Tunisia's National Forestry Research Institute measure wind speed, humidity, temperature, and other factors affecting the crops that grow in the shelter of trees and man-made windbreaks. Trees play a vital role in protecting the land, especially in the tropics. But the vast tropical rainforests are rapidly being depleted. One reason is the endless search for firewood, the main source of fuel in most developing countries. Overexploitation leads to destruction of the forest, and eventually the desert takes over. But the process can be reversed. In Senegal, researchers have planted fast-growing trees in arid savanna regions. The rows of hardy trees break the force of the wind and help to retain moisture in the soil. The leaves can be harvested as green fodder for animals. The acacia tree can be tapped for gum arabic, a valuable byproduct that provides additional income for the local people. The gum is used in many products, such as paints, pharmaceuticals, and even foodstuffs. Trees can also provide a beneficial environment in which to grow food, protecting both the soil and the crops. In addition, they act as nutrient pumps, drawing essential minerals from the subsoil and delivering them to the topsoil. Trees provide shade and pasture for livestock. Grazing animals fertilize the soil so that eventually it can support food crops once more. Agriculture byproducts such as processed cotton stalks, coffee pulp, and sugar cane can be made into silage and fed to animals. This source of fodder is especially important in the dry season, when there is little pasture. Researchers at the University of Alexandria in Egypt are studying the effects of these byproducts on several kinds of animals. This food can be integrated into the animal's regular diet of pasture grasses and legumes. Feeding trials have shown impressive weight gains. In Asia, fish is a more important source of food than is meat. Modern diesel-powered boats and new equipment have increased yields in the fishing industry. But has the marketing and distribution system kept up with the change? Who really benefits from the improvements? Does the fisherman get a fair share? Social scientists from the Marga Institute in Sri Lanka are studying the impact of new technology on the country's fish production and on the fishermen's standard of living. Some obviously have prospered. But for many people in the coastal villages, life has changed little. A community effort is required to haul in the huge seine net. But the size of the catch hardly justifies so much effort by so many people. And seine netting is destructive, as it kills many young, undersized fish. These nets are designed to catch young milkfish, but not to destroy them. They will be raised to full size in aquaculture ponds. Still, the nets cannot catch enough young fish to meet the demands from fish farmers. Another method had to be found. A breakthrough came in the Philippines with the first success of a new artificial breeding process. Researchers at the Southeast Asia Fisheries Development Center came up with a hormone injection technique to induce the milkfish to breed in captivity. Their discovery is now being tested on other hard-to-breed aquaculture species, such as groupers in Singapore. Water benefits us in many ways, but it also brings disease. Snails breed by the millions in the waters of Egypt's irrigation canals. Harmless in themselves, the snails provide temporary homes for schistosome worms, tiny parasites so small they can penetrate the human skin in contact with water. The result is a debilitating disease known as bilharzia, or schistosomiasis. The parasites breed rapidly in the human body, damaging organs such as the liver and spleen, gradually weakening their host over a period of years. But some years ago, Dr. Mohammed El-Sawi of the High Institute of Tropical Public Health in Alexandria found that some areas were virtually free of snails. His investigations led him to a wild herb called damsisa, common throughout the region. He discovered that the plant is lethal to snails, even in dried form, but harmless to other aquatic life. Laboratory tests have shown the effectiveness of the herb in killing snails under controlled conditions. Preliminary field tests have indicated that damsisa can also control the snail population in canals. Half of Egypt's people suffer from some level of bilharzia. Dr. El-Sawi's discovery will not cure them, but it may prevent many of these children from becoming victims too. In developing countries such as Guatemala, the rural household is the source of another health problem for children: intestinal diseases caused by parasitic organisms such as Shigella or Salmonella. The cycle of infection and reinfection is primarily a result of poor sanitary conditions in the contact between mother and child. For example, there may be a lack of hygiene in food preparation and in breastfeeding. In some regions, 40% of the deaths of children under 5 result from diarrheal diseases. Researchers from the Institute of Nutrition of Central America and Panama studied the transmission of disease in Guatemalan villages, the contamination level in the homes, the frequency of the diseases among family members, and the family's personal hygiene habits. In a field laboratory, they identified the many different types of pathogens. The result was a complete profile of the village health environment. But studies do little for the immediate need. The researchers developed and evaluated a health education program aimed at convincing the village women that disease is not, as they believed, a natural condition. It can be avoided. Improved sanitation technology is also essential to create a healthier environment. At a village school in Guatemala, the Mid-American Center for Studies on Appropriate Technology is testing a new kind of latrine. In addition to being more sanitary than the usual pit latrine, it has several advantages. The latrine is connected to a biogas digester, an underground vault in which methane gas is produced by fermentation. The effluent can be used as fertilizer, and sometimes it is recycled to produce more gas. In this project, some of the gas is used to cook hot food in the school cafeteria. But unless there is clean drinking water readily available, better sanitation will do little to improve health. In the rural areas of countries like Ethiopia, women are still the water carriers, even if their village is miles from the river. The big problem in rural water supply is the technology, most of which is imported and expensive. Pumps that look good at first often prove hard to maintain and almost impossible for the local people to repair when they break down. What is needed is an inexpensive, simple water pump that is easy to build and maintain. In Ethiopia, the Water Resources Authority is making just such a pump. Most of its components are produced from locally fabricated PVC plastic instead of cast iron. The prototype for this pump was designed at the University of Waterloo in Canada, and it is now being adapted and extensively tested all over the developing world. Although the pump was intended for shallow wells, it works with water tables as deep as 35 meters. The shaft is standard PVC pipe. The casing is metal to protect against damage by animals, but plastic pipe is strong enough for the piston rod. The only other non-plastic part is the handle, made of local hardwood. Local people can easily be shown how to maintain this pump, a piece of technology that is a practical means of bringing clean water and better health to the people in the rural areas. Mother's milk is also a key to better health. Breastfeeding provides excellent nutrition in the early months and safeguards the mother from becoming pregnant again too soon. Mexico considers this kind of family planning to be important, so researchers from the University of Yucatan are studying the physiology involved. Blood tests reveal the level of prolactin, a hormone essential to the resumption of ovulation. The duration of the safe period when there is no ovulation is longer in most developing nations than it is in industrialized countries. The project is one of several around the world attempting to find out why and to clarify the relationship between breastfeeding and birth spacing. Although the global birth rate has recently shown signs of slowing down, there are still far more young people than ever before, especially in the developing world. These young people need jobs, but if they are to find more productive employment, they must have the right kind of education. Educators in many countries are questioning the effectiveness of traditional forms of schooling. A number of innovative experiments in education delivery are underway. The one classroom school in Egypt is an example. 3,500 of these schools were established in Egypt over a 5-year period. Their success in bringing basic primary education to isolated rural areas is now being evaluated by the Egyptian National Council for Educational Research. The teachers are volunteers. The children range in age from 8 to 14. While the teacher works with one group, the children themselves become teachers. Is this the best way to provide education with limited resources? How can the developing countries prepare their young people for a world in which tradition and change must coexist? Questions like these remain to be answered. Adequate food, water, health, and education, and the means of informing people about them will not come overnight. Research takes time to produce results. But research and pilot programs are essential to the success of large-scale schemes. The Third World is beginning to develop its scientific and technological potential, a potential that will only be realized if countries and peoples themselves can define their own priorities and lay their own groundwork. The real beneficiaries of all this may be a generation away, but the researchers and decision makers of developing countries are working for that generation today. And the choices are theirs.